Hello, I'm Donald Prishak. Today I'm happy to welcome you to the Plastek Academy, a monthly webinar series. Within the plastics industry, we are grateful to be surrounded by many leading experts, individuals, organizations that are passionate about the work they do and who stay dedicated through cultural, environmental, and current event changes. Example of such are whom you will hear from throughout the scheduled series. Companies such as Beaumont Industries and American Injection Molding Institute, as well as IRG, Industrial Recycling Group, Mueller Technologies from the automation side of it, Penn State Barron from Mechatronics program, as well as Braskem on the resin, Direct Defense on cybersecurity, and finally a wrap up with the Plastek Group. As Executive Vice President of Sales and Marketing, it is my pleasure to join you here today as we kick off the 2022 series with a webinar presented by Plastek featuring my colleague, Research and Development Manager, and long-term friend, Peter Piscopo. I hope you enjoy this webinar designed for sustainability with e-commerce in mind. Thank you very much.
Well, thank you very much, Donald. I appreciate that introduction. We welcome everybody here today. That title of mine, Manager of Research and Development for the Plastek Group, is an elaborate title, but for me, it's design and development of plastic packaging for our group. And today we're going to talk about designing for sustainability, and we're going to talk about designing for sustainability with e-commerce in mind. So as we go into this today, what I'm trying to do is it's going to be first of all, I think there's never enough time to do this. And if I had more time, certainly we could talk a lot more about the content involved. But it's a fluid, dynamic situation what we have right now. Everybody knows that we're trying to use PCR materials more and more. It's more in a heightened sense in Europe than it is here domestically, but we're right behind. We're right on their heels, catching up to the same demand requirements. So with that in mind, this has been broken up into two sections: designing for sustainability, and then there's a segment where we talk about how to design for e-commerce. Big box stores are starting to go away fast and furiously. There are international standards set by Amazon on what we need to do to keep in mind to be able to supply in shippers. We're going to talk about all of that, and I'm hoping that you can glean some good information for yourselves, and together as we go into the future, we'll continue to learn. So we'll start with that in mind. Again, welcome. So we have a bunch of contributors here, and along with that, you'll notice there's a bunch of attachments for you that might be helpful. Some design guides, what we do with that standard from Amazon. We're going to talk about how to deal with that. What is the direction people are taking regarding recycled material, recycled content. That splash page that you saw with that little bit of a muted rainbow color is, what can we expect to get from recycled content? Those vibrant colors that we were used to with virgin materials is almost a thing of the past right now. But our agenda for this session is set right here before us. In part A, we'll talk about designing for sustainability, talk about definitions, PCR, PIR, rework. There's interesting videos I have embedded on what some people are doing to deal with how to cull out and deal with the recycling of separating. As we go down through this experience together, we're going to have to make sure that we have a clean stream of recycle it in the end. So we're going to talk about physical appearance, aesthetics, finish, and colors. In my world, what does that mean? I like to go into like the smallest detail. We do a lot of products with living hinge closures, and some of those hinges could be 0.010 of an inch thick. What do we do there when we're looking at recycled materials? Material availability, selection, and knowledge. what to expect from mold maintenance. We've learned an awful lot when it comes to mold maintenance and downtime because of manufacturing PCR material. We'll talk about that as well. On the B side, designing for e-commerce, knowing the protocol. You know, what are the standards that are out there? If you're going to put a product in a shipper and it's going to go, you know, in conjunction with one package, other items in a box, how do we ensure that it's going to get to its destination and still get there whole without leakage and breakage and problems that could be inside that shipper? Changing our thinking. You know, many times, you know, our products are marketing driven. Boy, they had to look good. They had to be so intuitive. You know, they had a telegraph function. All of that is still there, but we have to be careful with how we think about those things. Areas of vulnerability in the product design. Crumple zones. We'll talk about what that means in my mind. No overhung geometry is kind of self-expressive. Inset lids and effective lid latching. All of that we'll talk about in our agenda as we move forward. So some definitions. You know, how is PCR different from PIR and rework? You know, rework is waste generated, okay, within that manufacturing process. You know, it's reused within the same process rather than sold to another manufacturer, okay? So the ability to use rework as feedstock is considered the best practice in manufacturing. The resin is very close to virgin, high quality, since it's only experienced one heat processing history. So when we think about these different definitions, what does it mean? You know, what is PCR and how is it defined? So in my mind, this PCR material has already had a life cycle. What we don't know is how that material was handled. How was it processed? You know, was it overheated? Did it go outside of the processing parameters? What happens when that material might have been degraded and now it's in a recycling stream? How do we know? What's our degree of confidence that we're going to be able to use that material and get to the other side through testing protocols to be able to not have an event that could cause a problem? And then post-industrial, or PIR, is that resin that's been converted, you know, into a product that's out of spec and not saleable. So it's never really reached the customer or consumer. So some basic definitions of what we think about when we consider this type of material. Most municipalities, I don't know what it's like where you are, but depending on where we are here domestically in the US, it's single stream recycling, which is a real problem. You know, you can put all of this stuff into a recycling container, but somebody has got to be able to cull it out, separate it. And some municipalities are taking the care to have individual containers, as you see on the screen, paper, glass, you know, aluminum, plastic, and separating it more. But there's techniques that are out there. And of course, there's a lot more being driven from Europe and Japan now of how to deal with this in real time and not necessarily always put it onto the municipality. There's different techniques as we go forward into this. You can buy clean PCR, but the cost for that right now is very cost prohibitive. So what can we do about it, and how do we get our hands around it as we move forward? We're going to talk about that. So there's a technology called Prism. It's been out since 2016. What I like about it is that there are, you know, UV light sensitive markers that can be put on labels. They can be put into the material itself. You'll notice that, and I'll try and, you know, start this video here where you'll see just how effective it is, and at the same time how accurate it is, and what the potential yield would be for you to be able to see the result of it. So what you're seeing now is you're seeing just basic random plastic product that's being somehow separated. And you'll notice that as it goes through the separation process, there's an awful lot of stuff on one side. And then there is the selected stuff that we need on the side where we want to try and get that clean stream of recyclate. This only proves that using UV light and using these markers either through a label or a colorant or an additive into the material would lend itself to being able to separate materials successfully. So this has been active in the UK since 2016. Japan has adopted a process very similar to this. And I think we're going to have to look at it as we go forward, if we haven't already started looking at it. So we will we'll have to deal with it as time goes by. Now, I'm letting this video run just so that you can see how effective it is and what the level of accuracy is when this stuff is culled out. And you'll see in the bin that there is that label with the marker on it that's able to separate through UV light. There's the purity at 98% and yield at 93%. And then in the other bins, the material that was not selected, was not wanted. And that just shows you that with the technology we have today, there are ways for us to be able to help ourselves in this area. So when it comes to aesthetics, we talked about this in the opening. That slide that I'm using is it's important. It's you know, most companies are so marketing driven, and I'm okay with all of it. But in reality, if we're going to use, recyclate material, okay, if we're going to use PCR, a lot of the colors are going to be muted. I'm sure you all know that right now. I'm sure over time you've realized from your own research that the real vibrant colors that you get from virgin material is really not in view. Most of the reason for that is because as the plastic is collected and the convergence of all these different colors come together, it's hard to get that clear virgin-based material that you could then color. So it's already got the influence of all these different colors in there. So to get a red, it's more of a clay color. Black is easier, but whites are somehow a bit gray or muted. And you can see just in this little spattering of color what is real. And I just love the quote that I put up there. We're never going to be able to compete with perfect, and it's not fair or realistic expectation. Okay, so there's some verbiage there on the one side. Read up on it and see if you agree with me on it. I think it's what we're all going to deal with, aesthetics. So, and what we have is we have a partner, and KW Plastics is one of our partners in this recycled material. They are the largest here domestically in the US. I select these two resins right here because one on one side is a 20 melt FDA material, and on the other side is a pre-colored black. I select these two because you're going to see some of the work that we've done in our flip top closures. In this case, it's a 24 millimeter 410 flip top, bow tie living hinge. So it's, it's got a function. Okay. And at the same time, not only does it have to function, but it has to go through the normal protocol of testing, whatever that might be, to meet your standard. Could be top load. It could be, living hinge life. What we do, and you'll see it once we get into the brief video, is we have fixtures and test method equipment in our labs where we will set these closures up in a fixture and we will automatically flex these hinges with a counter, and we'll go and flex them and go beyond some of them 10, 15,000 flexes, certainly much longer than the life of the expected product. But we have to do that. What are you doing or going to do to ensure that you have the proper test methods and protocols in place to sell and market PCR material and not give up on the standards that are required to be able to put a product out on the shelf and know that it's as good as what it was once before. So let's go into it a bit. So here it is. It's in our case, this mold is a 48 cavity, 24 millimeter, 410, and it's linerless. We call it a crab claw or a linerless seal, but that's what this cap is. And typically, it's a virgin-based copolymer material. We get a great living hinge out of it. And I've got 3 videos here. And the first one is what that virgin standard copolymer is and how it functions. It's important to look at it. So, you know, here, this is how it would work in a standard virgin material. In this case, that hinge is 10 thousandths thick. We go into the next one, which is that 20 melt FDA white or off-colored white with the PCR material, but you'll see that it still functions nicely. And what I did here, and I'm trying to make it not fail, but I'm trying to bring that lid over just to see how lazy it becomes. What we've done here is thicken that hinge to 20 thousandths. Now we know, for those of us who know how to do the hinges, the bow tie has a what I call a hinge, I should say a stretching mechanism to it. And that tension that the hinge is under, if I was going to redo the insert set here for this 20 melt copolymer material and recycled material with a 20 thousandths hinge, I would stretch the outer bow tie a bit more so you get the action you need. And the reason why I'd go to 20 and we have to think that way now is, what is the life of this part? How can we, with recycled material, be smart in the product design, knowing that if there was going to be an issue, you've thickened up the weakest part of that cap, which is going to be that living hinge. So we see it in white, and now we see it in the black colorant. And we see the extremes in color because anywhere in between those two, you know, is where we would see, you know, how it would function. Would we see it slow down or become a problem? Would it crack? All of these have been vetted through our first article labs. And I suggest that if you are a product designer and you're the one who's putting the time in, that you're flexible. We're going to have to be flexible as we go into this with the PCR material. So that, in my world, I like to get into the details of it, and getting down to those little thin sections of whether or not we're going to be successful or not is where I would address it right at that point. And that's what I'm trying to illustrate here for you. And we move on. So our partner, one of the partners that we have out there is KW. As I mentioned before, they're the world's largest plastic recycler. It's important to partner with somebody that you know has that reputation. Those material sheets that I showed you are there. They are standards that are met by KW, and you know, you could rest easy knowing that they've done a lot of engineering analysis on their recycled content to be able to offer it as a standard. Again, it's a comfortable feeling that you know that they are large and they've seen it and been through it. Now, in my mind, this recycled content, this material will get better over time. But in order for it to reach that cleaner stream, it's going to take a little bit of time at the outset. We have to be smart with how we're doing our product design, and know that if there's an area of your part that is let's say, the most vulnerable, that's where you want to take precautions. We don't know until you go through it with your clients. What is the top load specification? How does it perform in accelerated oven test temperatures? You know, what happens in that fixture with the living hinge? You know, all of this are things that we can answer. So we're prepared to introduce products in this PCR material. Now, designing for e-commerce is going to be a big one for us. And I don't know if you've experienced it, but I had a client who called me a few years back when this all started to balloon up, and they were packaging a product and it was not making it to the destination whole, and it was a fluid inside the bottle, and it was just a mess because the package wasn't holding, and it was you were opening a box and having 32 ounces of product inside the box, and the package wasn't holding it. So they said, "Oh, what can we do, Pete? Can you help us?" And I said, "Yeah, I mean, I would redesign it, and I would do this." "Oh, we can't afford to do that. Oh, it's too late. We can't redesign it." Well, a lot of these pain points need to be addressed up front, and there are tools here to help you. Okay, so in the designing part of e-commerce, what I wanted to do here first is talk about what the standards are. So in the attachment I shared with you, there's the ISTA standard, basically driven by Amazon. Okay, and what's cool about this is for large enough companies, you know, like us, let's say at the Plastek group, we may use a third-party vendor to do our certifications, but it doesn't have to be. Because if you go through this and you see the slide that I have here on test and certify, you're going to see that certification can come relatively quickly by you doing it yourself. And so just a brief little video here. You know, it's called frustration-free packaging. Okay, Amazon drop test. This is just showing you that if you were packaging something inside this carton, what is required. Each corrugate surface has a number. Each flat surface has a number. Now you're going to document this just the way you see it here. You're going to do your own drop test from a given height. What Amazon does is they drop on every surface, every flat surface. They drop on every corner. You're going to record all the information. And then there are, right on the website, there are certification forms that you can fill out. It even tells you what tools to use to go through these things so that you can compile the information. If you're a small company and you want to be certified and you don't want to go through the cost of that third-party vendor, there's tools here to help you within these attachments so that you can get there without using or expending a lot of money. And it's pretty cool that they're allowing that to happen. So we move on. Now, third-party certification, there's multiple third-party labs around the world. Here again, you know, look it up. If that's really where you are and you want to do this through a third party, there's a multitude of companies that are out there. Look, it's a business for them. They're going to be prepared to deal with the Amazon shipping requirements because it's a business for them. And so, yeah, it's out there. It's important to know that the support is there for you. If you haven't looked and done the research, I love doing research for stuff like this, and it's out there. So take the time and check it out. Now, part of that test procedure, I just grabbed this integrity leak test, and it gives you just a quick rundown on what's required, and they're broken down into steps. Okay, so each step requires an action, right? Each action talks about the testing orientation and what the duration is. In this case, it's 8 hours. So there's a way for you to be able to have confidence knowing that you're good to go. And this is just a helpful tool for you as you move forward. Now, I have, you know, some examples of things that I want to go over with you here. I want to spend a little more time on this part only because I love doing stuff like this. It's design and development. And when I say changing your thinking, hide the obvious, plan for the worst, add crumple zones, better define what can be sacrificed, we're going to spend a little time here so that you see how I think. And like I say, you know, when packed with more than one, think of exposed geometry, vulnerable to a hit. Anything that's exposed from the bottle geometry is vulnerable. So I'm showing you these different areas that are overhung geometry that if you were putting a bottle in a shipper, many times it's not a single bottle and a shipper. Many times it's a bottle packaged with other things. And those other things, you know, you've seen, you know, drivers dropping packages off. I mean, stuff's being tossed onto your porch. I mean, imagine what's going on from the time it goes into the shipper to the time it goes into the truck to the time it gets to your door. So let's pump the brakes and think about what we should do here. Now, I have a couple packages that I wanted to illustrate for you, okay? And, you know, that, you know, not having overhung geometry is real important, okay? But keep in mind now, this could be one in a population of more than one inside a box. So anything that could cause a potential problem, we got to address it, okay? Because if I could just ride my hand up and see a package open, then it's not ready for showtime for putting a product inside a shipper. You know what? The design's beautiful. You know, you got big shoulders. You know, it's hiding the parting line of the cap, but it's just not gonna work if you don't address it in a way where you have a chance at success. Now here's one that I was impressed with. Okay, it's got a nice contoured design. There's nothing here that I can grab and say, oh boy, look at this, I'm opening the lid. So think about these things. Think about exposed geometry. Like I show those collision marks right here on this slide. Those are exposed. And you would say to yourself, well, boy, the design's going to be muted. You know, oh boy, but what about this? And you know, what about marketing? Would they accept it? Well, I say, you know, sometimes acceptance is easy when it equals success. Okay, so what we're trying to do is offer success, and what we're also trying to do is get you to think differently. And this is one of the areas you have to be careful of. That little picture on the right side, which shows the living hinge, if one of those little connected hinges breaks, it's not a good thing. The consumer is going to open it, it's going to hang on one side and be a mess on the other. And anyway, we're going to go forward and see what else we have here to talk about. So here's an example I found, which I felt was really, really, really close. Really close. I mean, I really like this execution. The shoulders of the bottle are big. The cap is somewhat minimized. You can see in the center of the screen at the top how the access to the lid latch is inset, okay? So it requires you to, you know, get a little more targeted on how you lift the lid. But there's more here. So much about this I really like, but there's more that could have been done. There's more. Because when you look at this package, the one thing that has not been protected is that big flat lid. And what happens if you take a hit down on the top of that lid? What are you going to do to ensure that the peg is going to be in the hole, make the seal, and not fracture? So what could we do there? How do we, as product designers, deal with it? So what I wanted to do is show you what I did. Let's go back a couple slides. I took this example and I said, okay, if I was going to design this and get rid of these pain points that you see, these collision areas, what would I do? So I went ahead and I just quickly modeled up a bottle, a cap, and now you can see if another product is riding up any surface of this bottle and it goes right up there and tries to hit to cause a collision, you've protected it. Anything with a large round, which would take that hit and glance right off, is what you see here on the picture on the left. And on the picture on the right, as you're trying to find that lid latch area that could cause a failure, where a package rides up, grabs that lid latch and opens, or could potentially open. Once the peg is unseated inside the base cap, all bets are off. It's a leaker, okay? Parting line is protected. The cap is inset of the bottle shoulder. All the good stuff was taken into consideration. So how do we deal with it from this point forward? How do we protect the top of the cap? That's where we're going to go now. So you'll notice, forgive me for that, that when you look at the cap in the molded position, a honeycomb shape. You know, we all have these phone cases. All right, in my world, I try and keep a phone case that's really going to be something that could withstand a lot of trauma, only because I'm not careful with it, you know. So I took the back of my phone, which has a little bit of a stand there, and I noticed that on the inside of that, they had that beautiful honeycomb shape, and I thought, oh wow, okay, I know what they did. They lightweighted it. They wanted to make sure that they could give some substance to this, and at the same time, you know, have substance, and at the same time, you know, core it out. But I wasn't thinking clearly, because I thought, oh wow, there's more here. If you notice, everywhere that you see a sharp corner on this thing is a rib. So as I get in there even closer, everywhere you see a sharp corner, there's a rib. So what does that tell you? If you were to take a hit down on the top of this surface, you'll notice I made a sketch in red. I could easily extrude that honeycomb shape now on the top surface of the cap. I don't need to worry about the radius corners of that cap. I only need that flat top surface. And if I allow that honeycomb shape to intersect the diameter of the peg or pintle on the lid side, anything that takes a hit down from the top is going to, there's the crumple zones I've been talking about, is going to prevent a straight line failure that could cut right through the peg, which would cause the hole to fail on the other side, and then you'd have a leaker inside the box. So when I talk about crumple zones and being smart with our product design, this is a real good example of what I would do. So time is, you know, I wish I had more time to go through this with you. And I also wish that it was more interactive with us. And I know there'll be some questions that could come up as we try to summarize all these things. Keep the standards I supplied with you at your fingertips. Get familiar with the international standard that Amazon lives by, and think about what it takes for you to be able to certify your own products. It's out there for you right within your fingertips, and all it takes is a little bit of thought. You don't have to go big third-party companies, you know, and labs that might cost a lot of money. Or if your company is large enough where that's in view, then go for it. I hope as we go further down the road here in these series that we'll expand on this and come back and see what else we can do to learn together. The end of it is that we want to try and use as much plastic that's in the environment today as we possibly can, continue to use it, and get that recyclage stream as clean as possible. And working through it together the way that we talked about today, I think is a good beginning. So I really appreciate your time with me today. Thank you.
Hi everyone, my name is Nicole Freeman. I am the marketing coordinator for the Plastek group. And I just want to take a moment to jump on here with you and Pete and say thank you to Pete. You've just heard from somebody who's been with the company as well as the industry for many, many years. And you can tell, I hope, in his presentation that he is passionate about the role that he plays and what he brings to contribute to the industry and in his design features. So as he's passionate about providing and educating, we thank him for participating in this Plastek Academy series, and is yet another reason why we know that you as an audience is here with us today as a part of this series to educate yourselves and continue learning for personal and career development. So as you see on the screen, and we have a few coming in already, we wanted to take a breath and give you the opportunity to think about what Pete had to mention today and write in some questions, whether it's about material or the e-commerce side of it, which we all know convenience, holidays, ease of access, marketing, as he mentioned, is important to business as well as consumers. So as that's a new area to discuss with e-commerce, please go ahead and use the question section on your dashboard as you see displayed on the screen here. And we will open with a couple of questions about today's topic. Okay, Pete, so I have a question here for us today.
Okay.
Can you take a moment to tell the audience how sustainable resins will perform over time in comparison to the virgin resins we use now? Do we yet have that information?
Today it's a fluid situation. We are in the middle of defining that now. And what has to happen, what drives us to know that we're able to perform as well as we did before, are the testing protocols we have. So what that means is so much more are we going to pay attention to the drop tests, to the living hinge thicknesses, to the top loads, what those standards are. We are not going to, our clients are not going to relax their standards. It's going to be up to us to meet the challenges that are out there today. And it's in view. It's something that we can do easily. It's tangible. So for us as a product designers and engineers, design engineers, it's a great challenge. I love it. So it's up to us to be smarter. It's up to us to think about, where the fatigue points or pain points could be and to design around them. Think about that. Think about the exposed geometry. Think about the crumple zones. Think about that weakest point of your product design. It could be a 10,000ths living hinge. It could be that exposed top surface of the cap. There are dart tests that we can do. A steel drop dart test on the top of that closure and test it in comparison to virgin material and know where we are and make educated, intelligent decisions on how to design around it. So it's a good problem to have. And I think over time, we're in the middle of it now. I think that to answer the question, we are not too far from the other side of it, to having the material behave very much like virgin material. It's just a matter of getting through it and accommodating what's required.
All right, thanks, Pete, for that.
Mm-hmm.
Another question we have from the audience is, do you expect waste contamination to significantly weaken plastic grades to a point where living hinges are not achievable?
That's a good question. And I would say to you that I've addressed it in this video, because I would never have thickened my living hinge from 10,000ths of an inch to 20 if I wasn't concerned right now. Now, what does that mean? Right now, we understand that if we go to a rail car and we take a sampling of what that resin is, and we do our spirals and melt flows and check for moisture content and certify it, we're still only certifying that needle in a haystack. So that's a good point, and it's out there and it's real. And I think that the only way that we're going to be able to get a clean answer on that is as we get through to the cleaner stream of recycling over time. So in the meantime, when we are not as confident, we design around it and we test and we certify and we look at drops, compression, living hinge thickness, and get that hinge to perform the way it should, as if it was 10,000ths thick, like you saw some of our videos. We're doing it now. But we're getting these hinges to perform exactly the way that they should, and we're thickening our hinges, and we're able to stretch the material, and that's more proprietary than that I'm willing to talk about now to get that hinge to perform the way I want it to, or the way that we want it to. But it was an excellent question, and it's just a way of how we design around it for now. And then if we're able to design around it for now, as that stream gets cleaner, recycling stream gets cleaner, you're going to be better for it on the other side of it. I hope that answers your question.
Great, thanks Pete, and thanks to the audience for submitting your question. We're gonna start wrapping up this webinar today, and if there are any questions that we weren't able to get to, or more accurately, questions that you had but are holding back on, because as Pete mentioned, there's a lot of research that goes into this topic, and it's trial and error to continue to find success and get things correct for the markets that we're in and the unique projects that we are applying it to. So with that said, a couple of references. My information as well as Pete's information is available here on the screen, so please take a moment to jot that down. And we are more than happy to receive phone calls or emails about the Plastek Academy series or the topic, anything that Pete can help out with. So feel free to reach out with us, maybe with something a little bit more specific to your unique situation.
Yeah, we're in a fraternity of problem solvers here. And in the bottom there where you see my telephone number, that's actually my cell number. So if you guys are struggling and you need some help and you want to bounce things off, don't be afraid to use it. Call me and ask, and I'd be happy to help you.
And one more reference before we leave, a few more seconds to allow you guys to obtain, again, the information that was given today. We had another question about the information being available after the webinar today, and Pete referenced many times about the documents he's provided. So on your dashboard, if you need to open that dashboard up and expand it, there is a handout section, and you will see several PDF documents there if you haven't found them already. So please be sure to at least click on them and open them, have them setting on your desktop there, so that after the webinar, they will be accessible to you to either print or download and view at your convenience. And lastly, as we exit today's webinar, again, we thank you all for joining us. It is our second annual series, so we are excited to see you return to this series as well as join us if it is your first time. And as we address many topics that are pain points for us in the industry, check back on our schedule throughout the rest of the year and get registered for those webinars.
Yeah, thank you. Thank you for attending.
Have a great day.
Bye-bye.